Here are some properties of logarithms. First of all, we talked about the definition of logarithm. Let's review that log base b of a, if that's equal to x, for example, you can rewrite that as b the base raised to x the exponent, and that will equal a. So it's just a rearranging of the same information, but one is a log function being done on the a, and the other one is an exponential function. The change of base rule we'll get to in a little bit. What this is nice for, especially, is when we don't have a base that we like. In other words, what if we wanted to do something on the calculator? Well, the calculator only has log, which is base 10, and ln, which is base e. And what if we had log base 3? So if that was the case and we wanted to find log base 3 of 100, and we were asked to find that and round it to the nearest tenth, well, what we would need to do is we could use this change of base rule, and we can take log of the 100 in base 10 over log base 10 of 3. So basically we changed the base. That's why it's called the change of base rule. We changed the base from a base of 3 to a base of 10, which when it's base 10 you don't have to write the base. That's just an understood base 10. And what you do is the way I remember which one to put on top and which one to put on bottom is the higher up number goes higher up on the top and the lower down number goes down on the bottom. And you put a log on each one of them separately. So log base 10 of 100 over log base 10 of 3, that's something that we could do on the calculator because our calculator has a base 10 on it. Now some of you do have the newer calculators that have a place where you can put your own base in there, and that's great, but if you don't, I just wanted you to know how you could use a log button that is base 10 to find a log that's base something else using this change of base rule. All the log rules relate back to the exponent rules in some way, and that's because they're inverse functions of each other. And so think about one of the exponent rules we had that said if you have the same base and you have those bases raised to different exponents, and yet there's an equal sign between them saying that a to the x minus 5 has to equal the same thing as a to the 12th, well then just by kind of logic, it would make sense that the two exponents would also have to be equal if the two expressions are going to have to be equal. So a to the something equals a to the something. Well, those two somethings are going to have to be equal to each other as well. So what you're allowed to do is you're allowed to just say, well, that means x minus 5 has to equal 12, and therefore we could solve for x by adding 5 on both sides, and we get x equals 17. So that gives us a way to solve for x if we need to. Well, a similar rule is that if log base b of x equals log base b of y, well then x has to equal y if that's the case. So think about an example. If you have log base 3 of x minus 5 equaling log base 3 of 12, well, it would only make sense that that would be equal to one another if the x minus 5 and the 12 were the same. So you could also say set x minus 5 equal to 12 and get x equals 17. So those are similar rules that just say if you have the same log with the same base and you have different things, they called it x and y just to say different things, that you're taking the log of, then you can set those two things equal to one another and solve whatever's left. We'll do an example of each one of these, but just to talk about the rest of the rules just basically. If you have log base b of something times something, then you're allowed to separate those into two separate logs, log base b of the first thing plus log base b of the second thing. So it starts as multiplication but ends up with addition, and it's the addition of the logs. And that's similar to a rule we saw with exponents where when you multiply two things you were allowed to add the exponents. That's a similar idea. And so then here we have log base b of x divided by y. And so when you take log of something that's divided, you're allowed to separate that into two separate logs that are subtracted. And so that may be useful for simplifying some logs on the next pages. Then another unique rule is if you have an exponent in the thing that you're taking the log of. So we're taking log of x to the y power. If the thing inside the log has a power on it, you are allowed to actually move that power down in front and multiply it by log base b of x. So it was log base b of x to the y power. We were allowed to take that exponent, move it down in front, and multiply it by the log without the exponent. And that is going to be a helpful rule as well. The next rule is just saying if you have a base of your log that's the same as the base of the thing you're taking the log of, so the base that goes with that exponent x, then you're allowed to just say the answer is the exponent. So if the bases match, the base of the log and the base of the exponent, then you're allowed to just say the answer is the exponent. Similarly, if you have the log itself in an exponent, and so it's b to the power of, and you're taking the power is actually a log itself, and the base of your exponent and the base of your log are the same, then you can just say the answer is the other piece, which is the x. And so those are similar rules. So always look to see if you have a base that's in the log and a base that's in the exponent. If they're the same, you can say that the answer is the other part. For different purposes, you're going to need to know how to use the rules forwards and backwards. And so in the first example, we're going to write two logs that are being subtracted as a single log. And so what you would want to do here is use the rule that says if you have two logs subtracted, you can go backwards and write them as a single log that's being divided. Now once you do that, you want to simplify the 32 over 2, and so we're going to say log base 4 of 16, that's 32 divided by 2. And then if it's solvable, you'll want to go ahead and do that. And so we want to, remember we can always set this equal to x, just to say log 4 of 16, log base 4 of 16 is equal to what, and the what can be your x. And then rewrite this as in exponential form, saying 4 to the x power equals 16, and just look at that and say 4 to the what equals 16, and that makes more sense to us, being used to exponents and not so much being used to the new idea of logs. So rewriting it as an exponential function might help us to look at it and be able to tell that x is 2, because 4 to the second power is what would give us 16. So sometimes we want to know actually what it equals, and there is no x, I just added the x in there. So when it says log base 4 of 16, you can simplify that to a 2. So that's one reason why taking two logs and putting them down to one log might be useful for some purposes, because we were able to answer that now. And the way they were in their original form, I wouldn't be able to answer that. Another rule we could have used on that same problem was right when we got here and we said log base 4 of 16. What if we wrote the 16 as a 4 to the second power? So we're just rewriting 16 as 4 to the second. Well, here's that other rule where if we have the base of the log and the base of the exponent being the same number, we're allowed to just say the answer is the exponent. So that was using one of the other rules, and we would have gotten the same answer. Many times in these problems, just like with exponent problems, we are able to get there several different ways depending on which laws we decide to use first. But either way, you should get the same answer. And sometimes they want us to move the other direction and take one single log and move it into several logs expanded. And so we use all the rules that we have, but we use them in the other direction now. And so we know now that the log of something that's multiplied can be written as the log of the 4 plus the log of the x. And then in the same way, when it's divided, we can write that as minus log of the bottom, the denominator. And so we use two rules in one, where you add when you multiply, you subtract when you divide, and those are now expanded, and for some purposes that might be useful. And also, notice this log was a base 10. It's understood to be 10. You don't have to write it when it's 10, so they left it off, and so we can leave it off as well. And that would be the expanded version of the original problem. For more examples, we're going to have to do a part 2 video, Properties of Logarithms, part 2.